Hi class, it's Professor Bork. I wanted to make a quick video about your my math Webassign homework number 2 from section 5.1. If you were able to join us in class yesterday, this was the question that we took a look at. The graphs are kind of funky and ambiguous, and we didn't really have time to get into them, but I wanted to make sure I had time to explain them for anyone who is still kind of confused or, looking to, even though they're ambiguous, trying to understand them a little bit better. So number 2 says, unless specified, all approximate rectangles are assumed to have the same width. Okay. And then it just says, evaluate the upper and lower sums for f of x equals 2 plus sine x from 0 to pi with n equals 2, 4, and 8. Illustrate each case with a sketch similar to the figure shown below. Round the answers to 2 decimal places. So the weird part, I believe, it starts from the first graph they show us. It looks like it's the graph that they're referring to, 2 plus sine x, but for some reason they have it labeled like from A to B, and A is kind of shifted off of the y-axis, and for our equation we're supposed to be going from 0 to pi. So right away, like the graph that they show you is supposed to be a quote similar sketch, is similar but not exactly lines up with what the graph is. So for whatever reason, I don't really know why, but that's how they started out. And then also the other weird part about this is they're not asking us essentially like left or right endpoints, sort of like they did in question number 1. For question number 2, they just want us to use quote left and right endpoints, but you don't need to necessarily look too far to see. I went ahead and put this in my graphing calculator as well because it's kind of funky. The problem is from 0 to pi, the graph is increasing and then decreasing. So we talked about how if it goes from increasing to decreasing on our interval, the left endpoint and the right endpoint, neither of them would be considered upper sums. So what I believe that they want us to do, which is where it could be like, okay, fine. Okay, all right. I don't really see the point, but that's okay. There's all kinds of estimating that might be helpful like in the real world. So we'll go with it. But what they're saying is the upper sum is literally just whatever rectangle could be drawn using either the left or right endpoints to make an overestimate. And then the lower sum would be, again, disregarding the whole left and right midpoint idea, just based off of either endpoint, which one would be a lower estimate. So in the graph, what they're trying to say, I think, is like, so the light blue squares that they have drawn here would be considered overestimates. Again, not even looking at left and right endpoints, just whichever endpoint would get you the higher value, use that one. And then for the lower estimate, the lower sum, same idea. You wouldn't care left or right endpoint, whatever, as long as you get you the underestimate. And then we would know in theory that the amount would be somewhere in between there. Again, we mostly just focus on like left, right endpoint, left endpoint, right endpoint, or midpoint, but it's okay. We can do this if they want us to. So I feel like that's part of what's confusing here is they kind of just like throw the whole left and right endpoint thing out the window. So what I'll do first, so let's go ahead and find the graph first, and then we'll come back and evaluate it, because I think even though the graphs are really kind of confusing, I want to make sure I explain them. So because there's just like a whole assortment of like yellow and blue labels, and then some of them have like the blue crossover. So I think, what they're trying, I don't even know what they're trying to go for. It's hard to say in some of these, but all of them have the same graphs, right? The curve that we're looking for from 0 to 2 pi is just this like almost like a parabola shape when it's bounded but from 0 to pi. All right, just kind of like the peak of the curve. And that's all the same. Now, this is, again, where it gets weird. They don't want us to think left endpoint, right endpoint. They only want us to think about like which would give us an overestimate and then which would give us the underestimate. So for n equals 2, for instance, they want us to use 2 rectangles. So thankfully they all have this. And hopefully it makes sense that they would each be counting by pi over 2. Okay, technically what you could always do if you're feeling confused about how big the rectangles are going to be, you can do a little b minus a divided by n type of vibe, right? Where a is 0 and b is pi. So we would say this like pi take away 0 divided by 2, which is the number of rectangles, right? So we're counting by pi over 2. That all matches. However, the weird part comes in again with the upper sum, lower sum part. They don't, again, want you to look left bound, right bound. They only want you to think about no matter which side of the interval we could look at, from 0 to pi over 2 or pi over 2 to pi, there's going to be one of the, you can make a rectangle that's an overestimate using like the higher y coordinate, and then there's going to be a lower estimate using the lower y coordinate. So like for instance, what they want us to select, which again, I understand why it's ambiguous, would be the graph that shows like a yellow section of the upper estimate, because what they're saying is like the upper estimate would be like the height of the rectangle would be like from 0 to 3, and then from 0 to pi over 2. So pi over 2 times 3 would give us the area of the upper sum, which is technically in left and right endpoint, like the right endpoint. And then they want us to then again abandon left and right endpoints. They just want us to make the next biggest estimate from pi over 2 to pi, which would also have a height of 3, which would be technically, in terms of left and right endpoints, the left endpoint. So it's weird because for the upper sum, they want us to use like a combination of left and right endpoints just based off of which is highest, which isn't really common, but whatever. I mean, who knows? There could be some application again that has us do that. So that's why they want us to select the graph that shows just essentially an overestimate and an underestimate, and then go from there. So then in terms of how to actually calculate it, right? Same idea. It's just kind of awkward because like the upper sum, if we use the graph to kind of help us a little bit, it's still going to be like the width is going to be the same, right? So I'll put a little squiggly approximation. So we'll say like pi over 2 is the width, and then we can just add the two outputs. The weird part again is that really because of the way it's set up, they want us to use like f of pi over 2 and f of pi over 2 for the overestimates. We typically wouldn't do that. If it was a left endpoint, we would use 0 and pi over 2. If it was a right endpoint, we'd use pi over 2 and pi. We hardly ever use both the same, but whatever, we can do that. So what they really want us to compute is pi over 2 times, we could plug in f of pi over 2, but also we have the graph and we can see here that it's just 3. So what it really comes down to is like pi over 2 times 6, which I guess would just be approximately like 3 pi. And they want us to find out what that is as a decimal rounded to what? 2 decimal places. So that would be like 9.42. And then they want us to repeat this, but again, not thinking about left and right, just which ones would be the lower estimate. So, okay, we can do that too. It would still be pi over 2, right? And then instead of thinking, again, it's not left and right endpoints, they just want the lower estimate. That would be essentially like using f of 0, because that has the lower estimate from 0 to pi over 2, if we're looking at the graph. And then again, not using pi over 2, using f of pi. So we're kind of just using the two outer outputs, which is not left endpoints, not right endpoints, like a weird combination in between. And again, using the graph, we could see that actually happens just at 2. So similar to what we did for the upper endpoints, we can do that same thing. So we'll say pi over 2 times 4, which just comes out to be about 2 pi, right? And again, they just want the decimal. So that would be 6.28. All right, so I hope that kind of makes sense. Let's set ourselves up with n equals 4 just to kind of make sure, same idea, they only want the upper estimate. So they went ahead and chopped this all off for us, and we got to pick out which one would be an upper estimate and which one's a lower estimate. Again, no left and right. So they just want us to use like the upper estimate, just looking through would be the yellow part is on the higher side, and then the shaded blue and yellow would be on the lower side. And we could do the same thing this time. The curve, the width is pi over 4, right? Because we broke it up pi into 4. So we can do that as well. Let's see here. Upper sum, I'm just going to set it up, and then I think you guys hopefully would be good to go from here. It would be pi over 4 times, and then now again, we're totally abandoning left and right endpoints. We're just looking at which ones would give us the higher values. So looking for my first section from 0 to pi over 4, it would be using the higher side of f of pi over 4. So I'm going to just say f of pi over 4, which I think is going to be like a little radical answer. So that's fine. We'll just kind of leave that chilling there with like an irrational number as f of pi over 4. And then moving to the next rectangle, they again use that highest peak of f of pi over 2, which actually we already figured that out from the last time. That was 3. The second rectangle, same vibes, okay, is 3. And then last but not least, the fourth rectangle that goes from like 3 pi over 4 to pi uses that 3 pi over 4, kind of similar to how it was on the first rectangle. Okay, so I would use my calculator to calculate this. Remember, technically the equation is 2 plus sine x. Okay, so we could just say, you could use varse if you want to. You don't have to. It's totally up to you. And we would use pi over 4 and also do the same thing for 3 pi over 4. Add that to 6, really, and then multiply that by pi over 4. So I hope that kind of makes sense. Again, I know it's a little awkward because they do not want us to use left or right endpoints. They just totally threw that out the window and want us to use just which one would be the highest, which one would be the lowest. That's it. So again, I hope that makes sense. We practiced a lot, mostly just talking about left endpoint, right endpoint, and then looking at those and saying if they could be upper and lower. We didn't really practice anywhere. You're like, okay, let's just look at the higher estimate, use that. Let's look at the lower estimate, use that. Which, I mean, in theory does make sense. I get what they're going for. I feel like that's what Archimedes kind of did sometimes, where you just sort of can then say, all right, my true number is somewhere in between here. Versus if you did left or right, would be a similar estimate, but not, you wouldn't really have a bound like that. Okay, I hope this makes sense. Again, keep me posted on whatever I can help you with as we finish this semester up. All right, thanks class. See ya.